So far we have done qualitative analysis, that is testing for elements present in the organic compound. Now we are going for quantitative analysis, that is estimation of elements present in the organic compound. Estimation of elements present in the organic compound means it is determining percentage of each element present in the organic compound. Okay. Now we are going to determine the percentage composition of the compounds, that is percentage of carbon, hydrogen, nitrogen, sulfur, oxygen, phosphorus, halogens. All these are estimated. Now see estimation of carbon and hydrogen first. A known mass of the organic compound on combustion will give CO2 and H2O. And whatever the mass of carbon is present in the organic compound, that is converted to carbon dioxide, and hydrogen present in the organic compound converted to water. So if you assume mass of organic compound is W grams, mass of carbon dioxide W1, mass of water W2 grams. So from the mass of carbon dioxide we estimate the percentage of carbon, from the mass of water we estimate the percentage of hydrogen. For example, you know carbon dioxide molecular mass 44, in that 44 12 plus 32, out of 44 carbon is 12 grams. So if 44 contains 12 grams of carbon, W1 grams of carbon dioxide contains how much carbon? That is W1 into 12 by 44 grams of carbon. So if W grams of the organic compound contains that much of carbon, 100 grams of organic compound contains how much? That is percentage. W1 into 12 W1 into 12 by 44 into 100 by W. Similarly, percentage of hydrogen, our hydrogen is in the form of water. Its molecular mass 18. Out of 18, 2 grams of hydrogen. So if 18 grams of water contains 2 grams of hydrogen, W2 grams of water contains how much? That is W2 into 2 by 18 grams of hydrogen. That much of hydrogen is present in the given mass of organic compound. That is W grams of organic compound contains this much of hydrogen. So 100 grams of organic compound contains how much? So that gives percentage of hydrogen. Now estimation of nitrogen. Nitrogen is estimated by two methods, that is Dumas method and Geldahl's method. In the Dumas method, it is applicable to all nitrogenous compounds. A known mass of organic compound is subjected to combustion in presence of CuO, copper oxide. So that carbon converts into carbon dioxide, hydrogen converts into water, and these two are removed. Now our focus is on nitrogen. So whatever the nitrogen is present in the organic compound, that is converted to free elementary nitrogen. In the process, if any nitrogen converts into oxides, those oxides of nitrogen are also reduced to free elementary nitrogen. Anyway, the nitrogen present in the organic compound is finally converted to free elementary nitrogen. The volume of such nitrogen is measured. Assume volume is VmL, mass of organic compound anyway W grams. So, as we discussed, that organic compound heated with copper oxide, these two are removed. So, nitrogen plus oxides of nitrogen. If at all oxides of nitrogen are formed, they are reduced back to free elementary nitrogen. So, mass of organic compound W grams, volume of nitrogen obtained in the experiment at STP VmL. As you know, nitrogen molecular weight is 28 grams. So 28 grams occupies 22,400 ml. Thus 22,400 ml of nitrogen weighs 28 grams. The VML of nitrogen given in the GMOS experiment weighs how many grams? V into 28 by 22,400. That is the mass of nitrogen present in the given organic compound. So 100 grams of organic compound contains how much? Into 100 by W. So V into 28 by 22,400 into 100 by W. On simplification, we get V by AW. So here V is volume of free nitrogen obtained in the experiment. W is mass of organic compound. Thus, in the GMOS method, nitrogen is estimated from free elementary nitrogen. Now come to the Gelder's method. In the Gelder's method, nitrogen is converted to ammonia. Say this, a known weight of organic compound is treated with excess of dilute sulfuric acid, so that nitrogen present in organic compound converts into ammonium sulfate first. That ammonium sulfate is finally converted to ammonia NH3 by treating with caustic soda. Thus, in the Gelder's method, the nitrogen present in the organic compound is converted to ammonia. From the volume of ammonia, from the normality of ammonia, we can determine the percentage of nitrogen. For example, mass of organic compound W grams, volume of ammonia V ml. We know that 1000 ml of 1 normal ammonia solution contains 14 grams of nitrogen. How it is? 1000 ml means 1 liter. 1 normal means 1 equivalent weight of ammonia present in 1 liter. 1 normal meaning is 1 equivalent weight of ammonia present in 1 liter solution. 1 equivalent weight of ammonia is 17 grams. 14 plus 3, 17 grams of ammonia. In the 17 grams of ammonia, we have 14 grams of nitrogen. That's why straight away you can write 1 liter of 1 normal ammonia solution contains 14 grams of nitrogen. So, VML of N normal, VML of N normal, capital N, normal ammonia solution contains how much? That's equal to V into N into 14, V into N into 14 divided into V into N into 14 by 1000. So, that is grams of nitrogen present in the given organic compound. So, percentage of nitrogen, see percentage of nitrogen is equal to, in the 100 grams of organic compound, V into N into 14 divided by 1000 into 100 by W, because mass of organic compound as usual W. So, how much we are getting here? 14 by 10, 1.4. So, 1.4 Vn by W. That gives the percentage of nitrogen present in the organic compound by Gelder's method. Here what is V? Volume of ammonia evolved in the Gelder's method. N, normality of ammonia. W, mass of organic compound. So, this you need to know. Now, that only I explained percentage of nitrogen in the 100 grams of organic compound. It is 1.4 Vn by W, as already have taken. Now estimation of sulfur, phosphorus, halogens. Sulfur, phosphorus, halogens, particularly sulfur and halogens are estimated by Carius method. In the Carius method, we use a specially made Carius test tube which can withstand high temperatures and high pressures. Anyway, just note down this point also. Geldols method is not applicable for nitro compounds, azo compounds and azoxy compounds. Also, it is not applicable for compounds containing nitrogen in the ring like pyridine. Okay. So, why it is so? Why it's not applicable for such compounds? Geldols method. In the nitro compound, in the Geldols method, nitrogen should be converted to ammonia. But in case of nitro compound, nitrogen is not converted to ammonia, not so easily converted to ammonia. In the azo and azoxy compounds, nitrogen is liberated as free nitrogen but not as ammonia. And also in case of pyridine, nitrogen is not so easily liberated as ammonia because that nitrogen involves in the aromaticity in pyridine. That is the reason though these compounds contain nitrogen, still it cannot be estimated in the Geldols method, but Dumas method is applicable to all compounds. Okay. See, in this Geldols method, one more point you can note down: copper sulfate will act as catalyst. Okay. Now, come to the Carius method. In the Carius method, first you are going to estimate sulfur. A known mass of the organic compound is heated with concentrated nitric acid first. That concentrated nitric acid will remove carbon and hydrogen as CO2 and H2O. And sulfur is converted to sulfuric acid. Then on treating with excess of barium chloride solution, that sulfuric acid converts into barium sulfate precipitate. From the mass of the barium sulfate PPT, you can estimate the sulfur. For example, mass of organic compound as usual, W grams, and the mass of barium sulfate obtained in the Carius method is 233. No, that is molecular mass. This is molecular mass, molecular weight of barium sulfate 233, because barium 137, sulfur 32, 4 oxygen 64. In the 233 grams of barium sulfate, how much sulfur is present? It is just one sulfur, so 32 grams. So, the W1 grams of barium sulfate is obtained in the experiment. So, here you write clearly 233 grams of barium sulfate contains 32 grams of sulfur. If 233 contains 32 grams of sulfur, in the Geldols, in this Carius method, W1 grams of barium sulfate which is obtained contains how much? So, that is W1 into 32 by 233 grams of sulfur. That much of sulfur is present in the given mass of organic compound, that is W grams. So, 100 grams of organic compound contains how much? That is percentage of sulfur, that is W1 into 32 by 233 into 100 by W. Here what is W1? That is the mass of the barium sulfate obtained in the Carius method. W is the mass of organic compound. Okay. Now, estimation of halogens. Halogens are converted to silver halides. See the known mass of organic compound on treating with nitric acid first and then silver nitrate. Finally, halogen is converted to silver halide. It is also precipitate. From the mass of silver halide, we can estimate the mass of halogen and then percentage of halogen. See mass of organic compound W grams, mass of silver halide W 1 grams, molecular weight of silver halide 108 plus X, silver atomic mass 108, X we do not know whether chlorine, bromine or iodine, that's why we assumed X. You know 108 plus X grams of silver halide contains X grams of halogen. So W1 grams of silver halide obtained in the experiment contains W1 into X divided by 108 plus X. I will write here W1 into X divided by 108 plus X grams of halogen. So percentage of halogen present in 100 grams of organic compound, that is W1 into X by 108 plus X into 100 by W. So what is this? W1 is mass of silver halide obtained in the Carius method. What is this X? Atomic mass of halogen. So W is mass of organic compound. So if it is chlorine, it is 35.5. If it is bromine, it is 80. If it is iodine, 127. Okay, this we have done already. This you have to note down. Now, estimation of phosphorus. Here, a known mass of organic compound, this time heated with concentrated nitric acid and then with sodium peroxide, so that phosphorus is converted to sodium phosphate. Then it is treated with ammonium molybdate solution. That sodium phosphate on treating with ammonium molybdate solution converts into ammonium phosphomolybdate, that is yellow precipitate. See, from the mass of this yellow precipitate, we can determine the percentage of phosphorus. Okay. How? See, molecular weight of ammonium phosphomolybdate. Its formula NH4 taken thrice, PO4 12 MOO3. Okay. Now its molecular weight is so high, 1877. In the 1877 grams, how much phosphorus is present? Only one phosphorus, so 31 grams. So 1877 grams of this yellow PPT or ammonium phosphomolybdate contains just 31 grams of phosphorus. In the experiment, as usual, we may be getting W1 grams of that yellow precipitate that contains how much phosphorus? W1 into 31 by 1877 grams of phosphorus. This much of phosphorus is present in the given W grams of organic compound. So, percentage of phosphorus is equal to W1 into 31 divided by 1877 into 100 by W. So, thus you can estimate the percentage of phosphorus. So, here what is W? It is mass of the ammonium phosphomolybdate obtained in the experiment. W is mass of organic compound given. 1877 molecular weight of ammonium phosphomolybdate. 31 is the atomic mass of phosphorus. Okay. Next is one more method is there to estimate the phosphorus. So before you see the estimation of oxygen, second method to estimate phosphorus. Here a known mass of organic compound is treated with, as usual, first with concentrated nitric acid and then with magnesia mixture. By treating with these reagents, whatever the phosphorus is present in the organic compound, that is converted to magnesium pyrophosphate, Mg2P2O7. Its molecular weight is 222. In the 222 grams of magnesium pyrophosphate, you have 2 phosphorus. That's why it is 62 grams. So, 222 grams of magnesium pyrophosphate contains 62 grams of phosphorus. In the experiment, we must have got W1 grams of magnesium pyrophosphate. So, W1 grams of magnesium pyrophosphate contains how many grams of phosphorus? That is W1 into 62 divided by 222 grams of phosphorus. That much of phosphorus is present in the given mass of organic compound, that is W. That's why percentage 100 grams of the organic compound contains how much? That is W1 into 62 divided by 222 into 100 by W. So, this is another method to estimate phosphorus. Here W1 is what? It is the mass of the magnesium pyrophosphate obtained in the experiment. W is, as usual, mass of organic compound. Okay. Finally, you can estimate the percentage of oxygen. It is unnecessary to estimate the percentage of oxygen because almost in every problem, the sum of percentages of all elements, 100 minus sum of percentages of all elements will give percentage of oxygen. Methods of determining mass of organic compounds. This method is useful to determine molecular weight of organic acids. It is called silver salt method. That silver salt method is useful to determine the molecular weight of carboxylic acids. The carboxylic acid or the organic acid converts into its silver salt, which on strong heating leaves a solid residue, that is metallic silver. So, this silver salt on strong heating will leave solid residue, that is silver. So, from the mass of the silver and the mass of the silver salt of fatty acid or organic acid, we can determine the molecular weight of organic acid. How? Say, the ratio of mass of silver salt of carboxylic acid divided by mass of silver is equal to the equivalent weights ratio, that is equivalent weight of silver salt of carboxylic acid divided by equivalent weight of silver. That means here mass ratio of acid to silver salt of acid to silver is equal to the mass ratio, equivalent weights ratio of silver salt to silver. So, in the problem, they will give mass of silver salt as well as mass of silver. They also will give, we know the equivalent weight of silver. You know, equivalent weight of silver is nothing but its atomic weight only, that is 108. So, we know all these three factors. We know the mass of silver salt of carboxylic acid, that has to be given in the problem. We know the mass of silver, and equivalent weight of silver is already known, that is constant 108. So, from that you can calculate equivalent weight of silver salt of acid. From the equivalent weight of silver salt, you can determine the molecular weight of silver. Okay. For example, there is a problem. You try to solve that problem. 0.38 grams of a silver salt of dibasic acid on ignition gave 0.27 grams of silver. Calculate the molecular mass of the acid. See, let us try to solve that problem. Silver salt weight is 0.38 grams. So, mass of silver salt of carboxylic acid 0.38 divided by mass of silver, that is 0.27 gram, that's equal to equivalent weight of silver salt divided by equivalent weight of silver. So, you are getting the equivalent weight of silver salt. From the equivalent weight, once you got the equivalent weight of silver salt, equivalent weight of acid, carboxylic acid, is equal to X. X is what? Equivalent weight of the silver salt, that is RCOOAg. In order to get the equivalent weight of carboxylic acid, that is RCOOH, you have to subtract equivalent weight of silver 108 and you have to add the equivalent weight of hydrogen. So, that is equivalent weight of RCOOAg minus 107, because you have to remove Ag and add hydrogen in order to get acid. That's why you know the equivalent weight of silver salt, that is X. X minus 107 will give equivalent weight of carboxylic acid. So, what is molecular weight here? Molecular weight of the carboxylic acid, that is dibasic acid. So, 2 into equivalent weight of carboxylic acid. If you multiply the equivalent weight with 2, you will get the molecular weight of carboxylic acid. You understood how you got the equivalent weight of acid? Equivalent weight of carboxylic acid is equal to equivalent weight of silver salt of that carboxylic acid minus 108 plus 1. You understood this step? Because in order to get RCOOH, I am removing Ag and adding H. So, minus 108 and plus 1. So, minus 107. That's all. That's the way you need to do. So, that silver salt method is for determining of molecular weights of carboxylic acids. Now, this is, in this method, chloroplatinic method or platinic chloride method that is useful to determine molecular masses of organic bases. Organic bases are amines. So, in this method, organic bases, they react with chloroplatinic acid. Chloroplatinic acid is H2PtCl6 to give chloroplatinate salt. This salt on strong heating gives a solid residue of platinum. So, this is our organic base 2B. B refers to base H2PtCl6. Because here this is chloroplatinic acid, it is dibasic acid. It has 2 H plus ions. We are adding 2 equivalents of base. That's why you got chloroplatinate salt. This on strong heating, it leaves a residue of platinum. So, mass of the chloroplatinate salt, which is given in the experiment, divided by mass of platinum, that is also given in the experiment, is equal to molecular weight of chloroplatinate salt divided by atomic weight of platinum. So, here molecular weight of chloroplatinate salt, how? 2B, we need to calculate the 2B plus chloroplatinic acid, that is 410, and if you sum up 2 hydrogens, 1 platinum, 6 chlorines, together will give 410. So, the molecular mass of this chloroplatinate salt is 410. So, its complete molecular mass is chloroplatinate salt molecular mass 2B plus 410 divided by atomic weight of platinum, that is 195. So, here I think you understood. Mass of chloroplatinate divided by mass of platinum is equal to molecular mass of chloroplatinate by atomic weight of platinum. If these two are given, you can calculate the 2B. Okay, this method is used to determine molar masses of organic bases. See, what is the molecular weight of the base? You calculate like this. Mass of chloroplatinate 0.49 grams divided by mass of platinum 0.195. Mass of chloroplatinate salt by mass of platinum is equal to molecular mass of chloroplatinate salt, that is 2B plus 410, that is B2H2PtCl6, 2B plus 410, molecular mass of chloroplatinate salt divided by atomic mass of platinum, that is 195. From that, easily you can calculate 2B. 2B gives 2 equivalents of base. So, equivalent weight of base is 1B. From that, you can calculate molecular mass. Because they clearly mentioned it is diacidic base. Diacidic base means you are going to calculate B or 2B. Diacidic base means you have to calculate 2B. 2B is 2 equivalents of base, that is equal to molecular mass of base. Okay. See here, one more method is there to determine molar mass of organic compound. That is very simple method. It is Victor-Meyer's method. In the Victor-Meyer's method, see here, a known mass of organic compound is vaporized. You got the vapors of organic compound. The volume of vapor you assume VML. Mass of the organic compound as usual, say W grams. A volatile organic compound is vaporized to give VML of that organic vapor. Of course, that is at STP. First see this one. See, VML of organic vapor, its mass is W grams. If VML weighs W grams, 22,400 ml weighs how many grams? Because at STP, 1 mole occupies 22,400 ml. 1 mole means 1 gram molecular weight. So, whatever the weight you get here, whatever the weight of 22,400 ml, that is molecular weight or gram molecular weight of organic compound. So, 22,400 into W by V, that gives molecular weight or gram molecular weight for organic compound. That is Victor-Meyer's method. It's very simple method, just one step. A known mass of organic compound is directly vaporized to give certain volume. From that volume, we get the mass of, you know the mass of that volume. You know this 22,400 ml always gives 1 gram molecular weight. What is the mass of that? 22,400 ml. That's all. Okay. Now, see that problem. In Victor-Meyer's determination, the following observations have been made. That is, mass of organic compound 0.17 gram, volume of air collected, vapor collected, not air. In fact, it is volume of vapor. Okay, we go to the next. Otherwise, I will give the problem. Please take down. In the Victor-Meyer's method, (0.1 gram of an organic compound in Victor-Meyer's method is vaporized to give 200 ml or 200 cc at STP. See, what is the molecular weight of that organic compound? So, straight away you can write like this. The mass of 200 cc of organic compound is 0.1 gram. What is the mass of 22,400 ml? So that gives molecular weight. Very simple. 22,400 into 0.1 divided by 200. 112. So it is 11.2 molecular weight. Okay. Like that, you can calculate molecular weights of organic compounds, organic acids, organic bases and organic compounds in general. In general, organic compounds molecular weights are determined by Victor-Meyer's method. Organic bases molecular weights are determined by platinic chloride method. Organic acids molecular weights are determined by silver salt method.